Welcome to another video, the same every time, IGCSE Maths and GCSE Maths, looking at the kind of questions that, apart from the numbers, are the same every time. We're still looking in this set of videos at speed time graphs. So here's an exam question. The diagram shows the speed time graph for 120 seconds of a car journey. Calculate the deceleration of the car during the first 20 seconds. If you've been watching the previous videos, you'll know your first move here is just to check that the units match up. So time is given in seconds, speed is in meters per second. So seconds for the time on the horizontal axis and seconds for time on the vertical axis. So seconds matches with seconds, so that's great, we can continue. So deceleration and acceleration are given by the gradient of the graph. So calculate the deceleration of the car during the first 20 seconds. So it's this part of the graph here, that's the first 20 seconds. So the gradient, change in y, divide by change in x, or rise over run. So change in y or rise, we're going from 10 to 18, so that's 8. And on the horizontal axis, we're going from 0 to 20. So it's 20 that way. So change in y, divide by change in x, rise over run, 8 divide by 20. And that will give me a 0.4. So 8 divide by 20, 0.4. There we are. It should actually go in there, I suppose, shouldn't it? So 0.4 meters per second squared. Remember what I said on the previous video, or maybe the one before that? Even though the gradient itself is actually negative, we never write deceleration with a negative sign. Deceleration is always a positive number. So the deceleration is 8 over 20, 0.4. Even though the gradient is negative 0.4, the deceleration is 0.4 because the word deceleration implies the negative sign. Part B, calculate the total distance traveled by the car during 120 seconds. So the distance traveled is the area under the graph. And a bit of an unusual shape for this one, I suppose, but the area under the graph, we can split this into shapes that we know. So we have a triangle just there. So there's a triangle at the beginning there. And we have another triangle just there, don't we? So we have another triangle there. And then, remember, it's the entire area underneath the graph. So we can make this rectangle just here, I think, can't we? So the entire area underneath the graph would be this triangle just here. So that triangle there, this triangle just here. There we go, that triangle, and the rectangle like that. So that would be the entire area underneath the graph. Slightly unusual shape for this one, I suppose, but nothing we can't deal with. So the first triangle, the base was 20, the height was 8, base times height divided by 2. This triangle just here, we're going from 90 to 120, so that's 30, isn't it? And the height is still going to be 8. No, it's not, is it? I'm wrong about that. The height isn't 8. And let's just... I'll just change that one. The height isn't 8, is it? So we're going from 10 up to 20, so the height is going to be 10, isn't it? So base times height divide by 2. So 30 times 10 divide by 2. And the rectangle, the base of the rectangle is 120. The height of the rectangle is 10, isn't it? We're going from 0 to 10. So the area of this rectangle is going to be base times height, 120 times by 10. Okay, so let's see, I'll write down all my method here. So 20 times 8 divided by 2, total distance travelled by the car, the first triangle, 20 times 8 divided by 2, plus the other triangle was 30 times 10 divided by 2, 30 times 10 divided by 2, plus the rectangle is 120 times by 10, so the total area underneath the curve there, 120 times by 10. Right then, calculate a job for this. So what have we got? We've got 20 times by 8, and that's divided by 2, plus 30 times 10 divided by 2, the two triangles, plus 120 times by 10, and that gives me 1,430. It's worth checking that they want the answer in meters, which they do, and our answer will come out in meters because the speed is meters per second and the time is seconds. Notice that I've shown all my method there. I am showing the examiner that I know that I should be working out area. Even if I do go wrong, like I almost did, didn't I, with my calculation there, by writing down my method, I'm still showing the examiner that I know that I should be working out areas and adding together all the area underneath the graph. Calculate the average speed for this 120-second journey. Average speed. Average speed is total distance divided by total time. So average speed is given by total distance divide by total time. Average speed, total distance, divide by total time. They want the answer in meters per second, so we have total distance in meters, 1,430. Total time, they tell us, was 120 seconds. I'm just going to double check. That was the entire length of the journey, wasn't it? Yes, 120 seconds. Okay. So average speed, total distance, divide by total time, 1,430, divide by 120. Right, it's a slightly annoying decimal, so I'm going to write my answer to 3 significant figures, so 11.9 meters per second, 3 significant figures. Notice that I am writing down all my working out here. I've written down my actual calculation, 1,430 divided by 120, and then my answer rounded to 3 significant figures. I'm just covering myself, making sure that I am giving the examiner what they want to see. And if the video was useful to you, then please do like and subscribe because that's useful to us. Thank you very much for watching. I do hope the video was useful, and I hope it's going to be useful to you when you're doing your exams. Get yourself into the marks, get yourself into the grades. Every mark matters, doesn't it? That's how you're going to get into the grades. Anyway, thank you very much. I will be back with the next video.